Example 1. Find the resistance of a 100-metre long drum of copper cable if it has a cross-sectional area of 1.5 millimeters squared. The resistivity of copper is 17.5 times 10 to the minus 9 ohm meters. So all of the information you need is in there. So this is example 1. Formula first. R equals rho L over A. Put the numbers in you're given in the question. Rho, this bit, is the resistivity, which is 17.5 times 10 to the minus 9. 17.5 times 10 to the minus 9 times the length, which was 100 meters, divided by the area of the cable, which was 1.5 millimeters squared. So 1.5. At this point, you need to remember why we did the area conversions on converting millimeters squared to meters squared, because this is 17.5 times 10 to the minus 9. This is ohm meters, so this is basically meters. The length of the cable was 100 meters, and at this moment in time this is in millimeters squared, so we need to convert it to square meters, and all we do is times 10 to the minus 6. So that's what you need to do at that point. And if you put that into your calculator, you should come out with 1.1666. And on it goes, you should see a dot above the 6. So I'll rewrite that as 1.17. So the resistance of this 1.5 millimeter squared piece of cable conductor, which is 100 meters long, is 1.17 ohms. Okay, I will take you through the key sequence at the end of this clip. So let's look at the second example. I'm going to present the information slightly differently in example 2. Still start with the same formula. R equals rho L over A. And the question says, find the resistance of a 50-meter long length of copper cable. It has a cross-sectional area of 2.5 millimeters squared. The resistivity of copper is 17.6 times 10 to the minus 6 ohm millimeters. So the last bit there, how the resistivity is presented, tells us how we're going to do the calculation. Let's put the numbers in. Resistivity 17.6, and it says times 10 to the minus 6. Multiply that by the length of the cable, which is 50. And we're then going to divide by the area of the cable, which was 2.5. So your conductor cross-sectional area is 2.5 millimeters squared. This question was presented differently, and what we have at the moment is this is in ohm millimeters. This, the length, is in meters, and this is in millimeters squared. If I take you back to the first one for a moment, we had meters, and we had to convert this to meters to make them all the same. In this one we have millimeters and millimeters. The simplest solution here is to change 50 meters to millimeters. And there are 1000 millimeters in a meter, so all we do here is times 1000 on the top. If you prefer, you could write 10 to the 3 for that, and that will be perfectly acceptable. So let's work that through. And if you put it into your calculator, then you should come up with 0.352 ohms. Okay. So there is a third example there. I'll let you work through that on your own, and I'll cover the example when I see you. What I will do, because I said I would do it, is I'll just have a run through the key sequence that you will do here to get through that calculation. Okay, so you're going to enter 17.5, and it's times 10 to the minus 9. So on your calculator you have the times 10 to the, enter minus 9, and then it's going to be times, then enter 100, and then you're going to do divide. I'll come down here, so divide, and it's 1.5. And if you remember, we made this 1.5 times 10 to the minus 6, so it's times 10 to the minus 6 equals. So look very carefully, this is in the bottom middle of your calculator display, and then you just do times 10 to the minus 9 times 100, divide 1.5 times 10 to the minus 6 equals. And if you do as I say, you repeat these words out, either out loud or in your mind, then this will help you remember the key sequence that you need. But this is a very, very important key for you. And in case you come up with an odd answer, don't forget the engineering button, and also Shift Eng moves the decimal point if you need to do so in some of the calculations that follow.